we are now recording. We're talking about expected value, where we have a formula for expected value, and it goes a little something like this. The formula for expected value, let's call it EV, expected value, or average value, is the sum of x times p of x. Now, that's not much of a formula. There's not much to it. But let's break it down into its little parts. What does the Greek sigma mean? Sum. X is the value. Usually it's a dollar amount, but it might be a point value. Like maybe the number of points you're going to get on a test for getting a question right versus the points you'll get for getting it wrong, which could be negative, like with some forms of tests. Okay? So we're going to add each outcome's value times, that's what this symbol is, the probability of it happening. We're going to add them all together. All right? So if you previewed example A, it was this guy has $3 bills, or so many dollar bills in his wallet, so you multiply $1 times the probability of randomly choosing one, plus the $5 bill's value, which is 5, times the probability of it coming out. Now that's example A, so you could check that out on your own. We're talking about number 3 here. So expected value is very popular in the world of fundraising or game playing, or quite frankly, gambling, where you're trying to figure out how much money your organization might raise by doing a raffle such as this. All right, so you're going to enter a contest where the first prize is $10,000. There are 50 second-place prizes for $1,000 each. That's pretty good. 100 third-place prizes for $100 each, and 1,000 fourth-place prizes for $20 a piece. One entry is allowed per person, and we're going to sell 50,000 tickets. Or maybe we're just going to give them away to people. All right? So let's see what happens. Down here, they have the x, p of x. Let that little I represent item or individual outcome or something like that. Each individual thing. So you could get $10,000, true? You could. What's the probability of that happening? 1 out of how many people are playing? 50,000. So we're going to put the probability of each in this row. How many people are going to get $1,000? 50 out of the total. 50,000 again. Now you can calculate all these. You can convert all these to decimals if you like, or you can leave them all as fractions. No problem. All right? How many people are going to get $100? 100 out of 50,000. And how many people are going to win a whopping $20? 1,000 out of 50,000. Your chances go up the smaller the prize. Of course, only one person gets the grand prize. So, how many people will not win anything? Well, it looks like we have 1,151 people winning something, right? If you add 1,151 people are going to win something, subtract that from how many people are in the contest, 50,000, and you'll get the number of losers. Can you do that for me? 48,000, how many? 849 people will go away losers. They will win nothing. So, 48,849 out of 50,000 is your chance of winning nada. Nothing. Zero. Zilch. Zip. Get it? Okay. If the contest were free, if they're just giving away this money, what are your expected winnings? This is expected value. This is where this formula, sigma, value times probability, comes into play. We need to take the value of the first place prize, which is how much? 10,000 times the likelihood of winning it. 1 in 50 grand. What does sigma mean? Sum. Add the value of the second place prize, which is what in blue? The value is 1,000 times the probability of it happening is 50 out of 50,000. Again, you could have converted all of these to decimals if you like. Sigma means add. What's the value of the next prize? $100 times 100 out of 50,000. Finally, we need to add the probability of winning $20 times the value of $20 in black right here. Technically, we should also add the value of winning nothing times its probability, but what's 0 times anything? 0, so that part can be left out to save us some writing and some time. So this is the equation to figure out the average value of playing this game, of entering this contest. If you type all this in, if you calculate all this out, it should come out to be 1.8. If I buy a ticket then, the average value of that ticket is $1.80. In other words, when they take all the prize money that they're giving away and divide by the number of people playing, it's like giving all 50,000 people how much each? $1.80 each. All right? Instead of giving one person 10,000 and 50 people 1,000 and so on, they could just give all 50,000 people $1.80 and say, "And wasn't that fun?" But what you can do is you can now say, okay, we're not going to give tickets away. What are we going to do? We're going to sell them, right? And if we sell them for $2 a piece, how much do we make per ticket? 20 cents. So you could multiply that by 50,000 and you get your total profit. Okay? Or if you sell it for $5 a piece, you're making $3.20 per ticket, right? So that's how we can figure out the profit that you would make in a scheme, a raffle like this. Okay?